Right now, in a clean room in Maryland, a machine the size of a car is hanging a few inches off the floor on 4 bungee cords. It has 8 rotors. Engineers are shaking it on purpose, listening for the frequency that could tear it apart. In 2 years, it leaves Earth. 6 years after that, it falls through an orange sky onto a world 300 degrees below zero. It carries a nuclear power source that can never be switched off. And it is going there because of something an older spacecraft found and could not explain. The machine is called Dragonfly, an 8-bladed flying laboratory built for the surface of another world. And the place it is going is Titan, the largest moon of Saturn. Before this is over, there are 3 things about Titan you need to hold on to. The first is a measurement taken by a small European probe in the final hour of its life, lying on a cold beach no one had ever seen, which told scientists the ground underneath it was damp. The second is a chemistry problem, simple enough to fit in 2 sentences. Titan's weather runs on methane. Sunlight destroys methane, and by every calculation anyone has run, Titan should have burned through its supply millions of years before the first human being was born. The third is a hole in the ground roughly 50 miles across, where the coldest large moon in the solar system once held liquid water, sitting in a bowl of organic sludge, and held it long enough for something interesting to happen. There is also a clock running. The launch window that sends Dragonfly towards Saturn opens in the first week of July, 2028, and closes about 3 weeks later. Orbital mechanics does not negotiate. Miss it, and everything waits. To understand why anyone would build a nuclear helicopter, we have to go back to when Titan was still a smudge. For most of the 20th century, Titan was the most frustrating object in the solar system. Astronomers knew it was enormous, wider across than the planet Mercury, and they knew it had a real atmosphere, which no other moon anywhere has. What they could not do was see it. In November of 1980, Voyager 1 flew within about 4,000 miles of the surface, closer than any spacecraft had ever come, and photographed a featureless orange ball. The haze was total, layer upon layer of organic smog so thick and so uniform that the best camera humanity had ever flown returned a picture of a tangerine. So NASA and the European Space Agency built something to solve the problem properly. Cassini left Cape Canaveral in October of 1997, weighing about 6 tons, roughly the size of a school bus. It spent 7 years crossing the solar system, borrowing speed from Venus, Earth, and Jupiter along the way, and arrived at Saturn on the 1st of July, 2004. Bolted to its side was a squat cone about 9 feet across, built by the European Space Agency and named Huygens, whose entire purpose was to be dropped. The expectations were modest. Cassini carried imaging radar which punches through haze the way airport radar punches through cloud, and the model suggested a global ocean of liquid ethane covering the whole moon half a mile deep. The mission would map a smooth alien sea and add an orderly world to the catalog. That is not what happened. The first radar pass came in October of 2004. The instrument painted a narrow strip of terrain, a few percent of the surface, and the team gathered around the first ground truth ever collected from beneath Titan's haze. There was no ocean. There were dunes. They were not small. Long parallel ridges of dark material stood around 300 feet tall and ran for hundreds of miles in near-perfect alignment, wrapping around the equator in belts later named Shangri-La and Belay. Together, they cover an area comparable to the United States, and the sand in them is not sand in any sense you would recognize. Those grains are organic, carbon compounds that formed in the sky, drifted down, and piled into a desert made of soot. So the models were wrong, and for 2 years the story was that Titan was dry. Then, in July of 2006, the radar swept across the North Polar region and found what everyone had been looking for in the wrong place. Dark patches turned up, dozens of them. Radar dark means radar smooth, and radar smooth at that scale means a flat liquid surface. Titan has lakes, it has seas. The largest, Kraken Mare, covers more area than the Caspian Sea on Earth. Beside it sit Ligeia Mare and Punga Mare, and around them a scatter of smaller basins, fed by branching rivers with cut banks and deltas that would look ordinary in an aerial photograph of Alaska. Except the liquid is methane and ethane, at a temperature far below anything Earth has recorded. This is where Titan stopped being an oddity and became something closer to a mirror. It is the only other body in the solar system with stable liquid standing on its surface. It has clouds, seasons, and rain. Because the air is thick and the gravity is weak, that rain falls in drops larger than ours, descending at roughly the speed of falling snow, gathering into rivers that carve valleys into ice as hard as granite. Every element of a working weather cycle is there, running on a liquid that would flash into vapor in a warm room. And that working cycle is exactly where the trouble starts. Follow the methane and you run into an accounting problem that has bothered planetary scientists for decades. Ultraviolet light from the sun, along with charged particles from Saturn's magnetic field, constantly breaks methane molecules apart, high in Titan's atmosphere. The fragments do not go back together as methane. They recombine into heavier compounds, ethane and acetylene and larger carbon chains, and those are too massive to stay aloft. They condense into haze, the haze settles, and it lands as the black sand of the dunes. Methane goes up as gas and comes down as sediment. The process runs one way only. Now run the arithmetic. Given how much methane sits in Titan's atmosphere and how fast sunlight is dismantling it, the supply should run out within tens of millions of years, on a solar system clock that is a rounding error, and the sun has been shining on Titan for more than 4 billion. So there are two honest options. Either we arrived during the last flicker of a process that is nearly finished, which would be an extraordinary coincidence, or something below the surface has been putting methane back into the sky for a very long time. Nobody has caught it in the act. Cassini looked for erupting ice volcanoes and found landforms that might qualify and might not. Something down there is venting, or releasing methane locked in ice, or churning material up from a reservoir we cannot see, which raises the obvious question of what exactly is down there. Cassini answered that one the slow way, by measuring the same places over and over for years. The radar team tracked recognizable landmarks across multiple flybys, then calculated where those features should appear on the next pass. Between 2005 and 2007, the landmarks kept turning up in the wrong place, off by as much as 20 miles. Titan's crust was sliding. An icy shell locked to the interior of a moon cannot do that. A shell floating on a liquid layer can. And when Cassini's radio team measured how much Titan flexes under Saturn's gravity, the numbers pointed the same way. Titan bulges by roughly 30 feet with each tidal cycle, where a rigid ball of rock and ice would barely move at all. Put it together, and you get a global ocean of liquid water. Probably salty, probably mixed with ammonia, acting as antifreeze, sealed under an ice shell 50 miles thick or more. Titan likely holds more liquid water than every ocean on Earth combined. Which sounds like the end of a satisfying story and is actually the beginning of the problem Dragonfly exists to solve. That water is buried under 50 miles of ice. The interesting organic chemistry is all on the surface. For 4 billion years, the two have had almost nothing to do with each other. Hold that thought, because before we reach the place where they meet, there's a piece of this story that has nothing to do with Titan, and without it, none of the rest exists. In February of 2000, a radio engineer named Boris Smeds was sitting in a windowless concrete basement underneath a dish antenna at Goldstone in the Mojave Desert. He worked for the European Space Agency out of Darmstadt, Germany, and he had spent months fighting to be in that room. The test he wanted had been rejected as unnecessary. Cassini was years into its cruise. Everything was nominal, and the link between probe and mothership had been checked on the ground before launch. Smeds pushed anyway, rebuilt the procedure around hardware that was already available, resubmitted it, and got approval. The idea was straightforward. Generate a fake Huygens transmission on Earth, beam it across the solar system to Cassini, and see whether the onboard receiver could decode it. Cassini was out past the asteroid belt by then, so a round trip took about 48 minutes. The data came back garbled. Smeds had a hunch about why. Huygens would be decelerating hard as it fell through Titan's atmosphere, and that deceleration would shift the frequency of its radio signal. The same effect that changes the pitch of a siren as an ambulance passes. His test signal included a simulated version of that shift. So overnight, he cut his own remaining test plan by more than half, and asked the ground station to transmit again with the shift removed. 48 minutes later, the answer came back clean. The receiver aboard Cassini had been built to lock onto a signal at a fixed frequency. Nobody had written the Doppler shift into the requirements, so nobody had designed for it. On descent day, that receiver would have heard Huygens perfectly well and been unable to make sense of most of what it said. The probe would have worked, the parachutes would have deployed, the instruments would have gathered the first data ever taken inside another world's atmosphere, and the spacecraft above would have written down noise, and nobody on Earth would have understood why. Smeds went home to Darmstadt and was not believed. Colleagues assumed his test setup was faulty. He spent months repeating the demonstration on the engineering model until, in September of 2000, the agency accepted it. An inquiry board confirmed the flaw. Then came the harder question, which was what to do about a broken radio receiver 800 million miles away. They could not fix the hardware, so they rewrote the flight. Engineers delayed the release of Huygens by months and redesigned the encounter geometry, moving Cassini onto a path farther from Titan and slower relative to the falling probe. Less relative motion means less frequency shift. The correction cost fuel, cost time, forced a redesign of the early tour around Saturn, and it worked because one engineer refused to let a test go unrun. On the 14th of January, 2005, Huygens hit Titan's atmosphere at around 13,000 miles per hour. It slowed under 3 successive parachutes, descended for 2 hours and 27 minutes through haze that never fully cleared, and landed on a dark plain with a soft thud, punching through a thin crust into something with the consistency of wet sand. It was, and still is, the most distant landing ever performed by anything humans have built. And the channel failed anyway. A command that should have enabled one of Cassini's 2 receivers was never sent, and roughly half the images were lost, along with the experiment designed to measure Titan's winds. Except that radio astronomers, anticipating this kind of risk, had aimed large ground-based dishes at Saturn and locked onto the probe's raw carrier tone directly, across 750 million miles. From the drift of that single tone, they rebuilt the wind profile the lost channel was supposed to deliver. Then came the detail I promised you at the start. Huygens survived on the surface for about 70 minutes before its batteries gave out. During that time, heat leaking from its own instruments warmed the ground it was resting on, and the sensor sampling the surrounding air watched the methane level climb. The soil was wet, not with water, but with liquid methane, sitting in the ground the way groundwater sits in soil after rain. Huygens had landed on a floodplain, and the flood had not been all that long ago. That single reading meant Titan is a running machine rather than a preserved corpse. Liquid moves through the ground there, carrying material, mixing it, burying it, exposing it again, which brings us to what Cassini found in the sky. The spacecraft carried a mass spectrometer, an instrument that sorts molecules by weight. On repeated passes, it dipped to about 600 miles above the surface into a region of the upper atmosphere so thin it should have held nothing but simple gases. Instead, it found heavy molecules, and some of them were very heavy. It detected negatively charged organic compounds hundreds of times the mass of a hydrogen atom, complex carbon structures assembling themselves in near vacuum out of nothing more than nitrogen, methane, and sunlight. Titan's atmosphere is a factory. Sunlight breaks apart the simple molecules at the top. The fragments recombine into larger structures as they sink. And by the time that material reaches the ground, it has become the black organic sand of the dunes. The moon has been running this process for billions of years and stockpiling the product on its surface. That inventory includes the raw feedstock for the chemistry that leads to life. It holds nitriles, hydrocarbons, and compounds closely related to the building blocks of proteins and genetic material spread across an area the size of a continent. One ingredient is missing. The missing ingredient is liquid water. On Titan's surface, water is a mineral. It is bedrock, frozen so hard that impacts crack it like stone. So the organics sit on top of the ice and nothing happens. 2 halves of a chemistry set, kept in separate rooms for 4 billion years. If this is the kind of story you want more of, subscribing costs you nothing and keeps this channel pointed at missions like this one as they actually happen. There is a launch window coming, and I intend to cover every step of it, because sometimes those rooms open. Silk Crater sits near Titan's equator, about 50 miles across, and Cassini's infrared instrument showed that its floor and surroundings are unusually rich in organic material. Consider what an impact does to a world made of ice. When a body a couple of miles wide slams into Titan at cosmic speed, that energy goes straight into heat, and the ice does not shatter so much as melt. Modeling of a Selk-sized impact suggests it produced roughly 50 cubic miles of liquid water, pooled beneath the crater floor and capped by a lid of refrozen ice. That lid is the important part, because ice is a good insulator. Under it, the meltwater cools slowly, and slowly here means thousands of years at minimum, with the deepest pockets possibly staying liquid for tens of thousands, especially if ammonia from Titan's interior lowered the freezing point further. Now consider what was in that pool. There was liquid water, warmed well above freezing. There was the accumulated organic material of the surface, stirred in by the impact. There was phosphorus, sulfur, and iron delivered by the incoming body itself. Every ingredient chemists put into an origin of life experiment was held together at the right temperature, in the dark, for longer than human civilization has existed. Laboratories on Earth run those experiments for weeks, sometimes months. Silk Crater ran one for millennia. And this matters more on Titan than anywhere else. There is no plate tectonics recycling the crust, and no liquid water weathering to dissolve the evidence. Whatever chemistry happened in that melt pool froze in place and has been sitting there ever since. Nobody has ever walked into a natural laboratory like that and read the results. Which is the entire reason for the machine in the clean room, and for the strange fact that the hardest place to land in the solar system is also the easiest place to fly. Titan's atmosphere at the surface is about 4.5 times denser than the air outside your window, and the pressure is roughly 50% higher than sea level on Earth. The gravity is about 1/7 of ours, weaker than the moon's. Thick air and weak gravity are the 2 things a wing wants. On Titan, a reasonably fit person with strapped-on wings could take off under their own muscle power. Getting airborne there costs a fraction of the effort it costs here. So NASA is not sending another rover to crawl across a few miles of ground in a decade. It is sending an aircraft. Dragonfly is about 13 feet long, roughly the footprint of a compact car, and will weigh close to 1,000 pounds on the surface. It carries 8 rotors and 4 coaxial pairs, so losing any single rotor does not end the mission. It looks like an oversized delivery drone built by someone expecting the apocalypse. Its power source is a radioisotope generator. Inside sits a mass of plutonium dioxide, decaying steadily, giving off heat that solid-state devices convert into electricity with no moving parts at all. It cannot be switched on or off. It has been warm since the day it was assembled and will still be warm long after the mission ends. Sunlight is out of the question. Titan sits nearly 10 times farther from the sun than Earth does, and that weak light then has to fight through the haze. Midday, there is about as bright as deep twilight here, so solar panels would be useless, but the generator only produces around 70 watts, less than a bright household bulb and nowhere near enough to lift a 1,000-pound aircraft. The solution is patience. Dragonfly trickles that power into a battery for days on end. A single Titan day lasts about 16 Earth days, so the machine spends most of its life parked, charging, taking measurements, and listening to the weather. Then, when the battery is full, it spends the whole charge in one burst. It flies for half an hour, then rests for 2 weeks. The waste heat is not wasted either. Warm air from the generator circulates through the body of the lander to keep the electronics from freezing solid, and the whole structure is wrapped in a foam blanket about 3 inches thick. Then there's the problem of being alone. A radio signal from Titan takes roughly 80 minutes to reach Earth, and another 80 for a reply. Nobody's flying this thing. When Dragonfly lifts off, it navigates by itself, scans the ground with cameras and laser ranging, picks its own landing site, judges whether it is safe, and commits. Every flight is a decision made by software more than 1 billion miles from the nearest engineer, reported home long after it is settled. Each hop can cover up to about 5 miles, and across a science mission planned to run more than 3 years, the vehicle should travel well over 100 miles, farther than every Mars rover in history combined. It lands first in the Shangri-La dune fields, then works its way, hop by hop, towards Selk. Once there, the instruments go to work. A drill in each skid pulls material from below the surface and feeds it to a mass spectrometer, which heats the sample and identifies it molecule by molecule. A second instrument fires neutrons into the ground and reads the gamma rays that come back, surveying a site without touching it. A weather station and a seismometer listen for wind, moonquakes, and the deep tidal flexing that gives away the ocean underneath. Getting to the ground is its own ordeal. Dragonfly arrives, folded inside a heat shield, hits the atmosphere and slows under parachutes for roughly 2 hours because Titan's thick air stretches the descent into something almost leisurely. Then, still in the sky, it drops away from the parachute, spins up its rotors, and flies to its landing site under its own control. No spacecraft has ever arrived at another world by flying itself down. All of that is under construction right now, which is where we started. Assembly of the flight vehicle began in March of this year at the Applied Physics Laboratory in Maryland. On the 1st of June, engineers finished testing the heat shield material at a solar tower in New Mexico, where hundreds of mirrors focus sunlight onto one point to reach around 4,500 degrees Fahrenheit. They deliberately built flaws into the samples, and the material held. On the 29th of June, the team delivered the finished fuselage ahead of schedule, after a month of shaking it and pressure testing it to prove the frame can survive launch, entry, and landing. On the 1st of July, integration began. Right now, technicians are threading the wiring harness through that fuselage, the cables and connectors that turn a structure into a spacecraft. And that is the vehicle hanging from bungee cords a few inches above the floor, while engineers drive vibrations through the rotor mounts and watch how the frame answers. One of them described those hours suspended in the air as something close to Dragonfly's first flight. The launch window opens on the 5th of July, 2028, and closes on the 25th. The rocket is a Falcon Heavy lifting off from Kennedy Space Center. After that comes a 6-year cruise, arrival in the year 2034, and a science mission running past 2037. Take a step back and look at the shape of this. Cassini launched in 1997. It took 7 years to arrive, 13 more to finish its work, and it burned up in Saturn's atmosphere in 2017, deliberately destroyed, so it could never contaminate the moons it had studied. The questions it raised about Titan get their answer in 2034 at the earliest. That is 37 years from the launch of the question to the arrival of the answer, longer than most careers. Some of the scientists who argued for Titan in the 1990s did not live to see the lakes confirmed. Some of the engineers assembling Dragonfly this summer will be retired before it flies, and a few of the people who will eventually operate it are sitting in a school classroom right now with no idea what they will spend their life on. We are a species with a lifespan of decades, working deliberately on projects that outrun us. There is something almost unreasonable about that. It requires believing the answer matters, even if you never personally hear it, and that whoever does hear it will be worth the trouble. Titan will not tell us whether life exists there. Dragonfly is not built to find life, and the scientists running it are careful to say so. It is built to find out how far the chemistry got, whether the reactions that preceded life on Earth also ran on a world with no surface water, no real sunlight, and a cold that would freeze the air in your lungs. The answer tells us whether that pathway is a fluke of one planet or a feature of the universe. If it turns out to be common, the sky gets a great deal more crowded. And somewhere in the middle of the next decade, if the window holds and the machine works, there will be a moment when a small light rises off a black dune field under an orange sky, hovers, turns, and moves away across terrain no one has ever seen. No one on Earth will know it happened for another 80 minutes. The signal will still be in flight, crossing the dark, carrying the news home to a room full of people who have been waiting most of their lives to hear it. A light moving over the dunes, and 80 minutes of silence behind it.